So 3-1 we were doing derivatives. So derivatives we had like a pretty big process for figuring it out, had to do with slopes and all these things, and I told you there was a better way coming that would be more time efficient. So today is it. So before we're done, we'll fill in about 4 rules over here. But first we'll take a walk over here and see if we can remind ourselves of some old things. So if I asked you to do y equals 8 and make a graph, anybody have a recollection where y equals 8 would go?
On the y-axis.
On the y-axis, I should go
8
up 8
horizontal line.
and then draw a horizontal line. Then we'll try to connect back to yesterday. Derivatives, a synonym for derivatives. A couple possible words that are derivative synonyms. Any recollection? A derivative is a blank. There's an R word, or there's an S word. Slope will work. Rate would also be acceptable. But when I ask you to find the derivative, I'm asking you to find the slope. So let's think back to Algebra 1. What is the slope of this line? 0. Anytime I give you an equation that's y equals some number, the derivative, the slope, would always be 0. And so that's rule number 1 if I work my way slightly back left. If I give you y equals, C stands for just a constant, some number. If y equals a number, the derivative, the slope, the rate for that is 0. If I tell you y is 8, period, how much is that changing? It is not. So what is its rate of change? Nothing. If I give you y equals x squared, well now that's a different ballgame. Okay, what's y equals x squared look like in graph count?
Is that a problem?
It is. So we get ourselves a U shape. At the bottom, what's the slope when it's like this? That's a 0 slope. What's a slope like this about?
Negative.
It's a slope like that about?
Positive.
Positive. As it moves, it's getting steeper, so the slope is getting increasing. It's changing all the time. So there's no simple answer to this. It's going to be a formula. So I'm going to tell you the derivative of x squared
2x.
is 2x. You've seen this before,
I know
so
it
you're
is.
spoiling the surprise. So we'll take somebody who hasn't ever seen this before. Do you have a guess what the derivative of x cubed would be?
3x.
It is 3x squared, so you're close. And then are you up for trying to anybody, we'll pick on you over there, take a guess at x to the 4th? Cube is correct. Then we'll make you guess another one.
5x to the 4th.
It's always going to go that way. So I'll take a stroll back to the left. So if we're doing derivatives of x's to powers, what's one thing that's always going to happen? What's the pattern of what you're doing? We have x to a power to begin with. We do the derivative. Now how's it look?
Do you have 1 to the power?
Warm. The new power
It's 1 less.
is 1 less, so I could call that and
Minus previous power, which is...
we're always subtracting.
Oh, 1. Yeah.
And then what else is happening? We always did the power always subtracted by 1.
Then you multiply
Okay, in the front we multiply by
the power.
which I was originally calling
N.
n. So whatever the power was, it goes and multiplies in the front. Power goes down by 1. Question about that? How about this one?
Just be 1.
It would just be 1. There's a few reasons we could explain that. Where do
Because they have an invisible exponent of
okay,
1.
has an invisible 1 there. So if we slide the power to the front, the 1 slides to the front. So we'd have 1 x to the 0. Anything to the 0 power is 1. So that would be a decent explanation. Let's go algebra 1 based explanation. If I ask you to graph y equals x, thought on that?
It's just a slope through the origin.
Yeah, we go through the origin.
Just 1 over 1.
Yeah, up 1 over 1. We've got like a y equals mx plus b kind of thing going on here. The slope is always the number with the x. Like that has a slope of 1. It's like if I give you this and say, what's the slope? It's 2. So if I point at this and say, what's the derivative? It's 2. Because derivative means slope, rate. It's all the same thing. So if you have something that looks like a y equals mx plus b, I shoot you this, what's the slope?
7.
7. What's the derivative? 7. Now, could you insert that invisible 1 and do the whole process? Sure. But just keep in mind as you do all this stuff, the derivative is the slope. If you have something that from previous math you knew how to do the slope already, that's still valid. X to the negative 2, what would that become?
Well, don't you have to, there's like 2 steps, right? We have to put
No,
it
it's
on
the same
fraction.
process. It's just negative numbers make people mad.
So it's just negative 2
Negative
x to the negative 3rd.
X to the negative 3rd is a win.
Do you have to make that into a fraction?
No,
No.
optional. Question about that column? I was going to do this anyway, but he mentions it, so now I definitely will. This could be alternatively written. So if you looked in the back of the book for this, what's another way this could be written? And he already said it has something to do with fractions. What fraction is this?
1 over x to the 2nd power.
1 over x to the 2nd power. Negative powers just flip things. So a negative power should just normally belong on the bottom, unless it's already on the bottom, in which case it really belongs on the top. So if I wanted to rewrite this as a fraction, it would be
1 over 2x to the 3rd.
I'm going to go and agree with the x to the 3rd part.
2's on, negative 2's on
The
top.
negative 2 remains where it was. The only way the negative 2 would move is if I put it to like a negative 1 power or something. Then it's got to also move. But that's going to just own the top. Negative powers can flip. Question about column 1? Same process, just this time when we bring the number to the front, it runs into another number, and they're multiplying there. So if that 2 slams to the front and it's multiplying, we've now got
6x
6x
1 power.
1, and I don't need to write 1. 5x we already talked about over there. The derivative of 5x would be 5. That's a y equals mx plus b kind of thing. If you see just an x, the slope is the number with the x. Questions there? Then let me take a step back this way to illuminate these rules. So we just had a problem of this form. If you have some number multiplying stuff, what you want to do is the derivative of the stuff, and it's just going to multiply the number that was weighted. Okay, so the English version of this rule is if you have stuff multiplying a number, do the derivative of the stuff like you always have, just make sure you multiply the number with it. This will apply to the next thing. If we're trying to have more algebra stuff plus algebra stuff, when you do the derivative, do the derivative of one, do the derivative of the other one, and just let them keep on adding each other. They'll each operate independently. And we're about to hit this in the next question when I stroll back. In calculus lingo, the u's will always refer to an algebra thing, like an x squared or a square root of x. The u's and the v's are like things. The C's are just numbers. So this is representing like 2, whatever algebra thing you've got. Scrolling back this way, if I asked you to do the derivative of 4x squared, you could. That's just going to be
Yes.
8x. Then move on. 5x cubed has nothing to do with that. Just start again.
15x squared.
15x squared. And since it was adding, I'll just let them add. 7x becomes 7. How about the 8? 0. Disappear. Doesn't matter. Numbers vanish. Questions to there? This one, anything that is a fraction, I'd suggest you do a rewrite. The way over here we did these rewrites, I would do a similar rewrite, just like in reverse
Because
method.
you're adding to the exponent on the bottom.
Can you rewrite this one?
X negative.
X negative fifth. We haven't done any calculus. We just did a quick, like algebra 2, make it look different move. Now we can do the rule. Derivative time,
Negative 5x.
5x,
The negative 6.
all true. They're not going to care if you put it back, but if I demanded that you put it back for some reason,
Negative 5 on top.
negative 5 on top,
X to the 6.
agree. I don't care if you put it back. It's not a bad skill to have. Let's put it on that. So let's rewrite this one. Anybody know a way you can rewrite that to look a little different? I'm going to say 4/3. And just put the x squared off by itself. That's legal. If that helps you like picture it better, sometimes it's just an easier picture. And then do the derivative.
8x over. Oh, just 8x, right? Does the 3 disappear? Oh, because that's all part of the same thing.
Yeah, it's like a number. So like the 2 is coming to the
8 over
front.
6, which is 4.
Disagree? Let's settle on the power of x. X is going to be to the 1 with that. If 2 goes to the front, it multiplies. Anybody a theory?
Is 8 over 3?
It is 8 over 3. Because the 2 is like it's invisibly over
Oh,
1. So 2 over 1, 4 over 3, multiply across 8 over 3. Same thing. If we rewrite this, I can instead picture this as
5 over 7
5/7
times x to the 3.
x to the 3rd. And then let's do the derivative.
15 over 7 x to the 2nd.
Okay. Question down that column. Just figure that out of there. No, I drew my line in the wrong place. Confused myself. Those were the answers. Could have left that there. That was just fine. Anything over there? I only confused myself. Rewrite.
Four nines.
4, 9.
And the x squared is
X what?
x squared.
Negative.
Negative 2. Why negative power this time?
It's on the bottom.
It's on the bottom. Anytime the x is on the top, just leave it the way it was. If the x is on the bottom, the little rewrite it with a negative power. And then do the derivative.
Negative 8 over 9.
Yeah,
X to the negative 3.
true. Rewrite.
Just 8 times x over
8x.
4. Negative 4.
Negative 4. Derivative.
Negative 32 x to negative 3.
Okay. Do family, rewrite, root x, rewrite.
X to the half.
It is x to the half. Derivative?
So it's just half X.
Half x.
Negative a half.
Negative what?
Negative a half.
Negative a half is true. Rewrite?
3 over 2. X 3 over 2. Or 2 over 3, sorry. So 1 over?
1 over 3. Derivative?
One 3 over, well, 1 3 times x. Negative 2 over 3.
Agreed. Something like that. And one more. 7th root x to the 10th. Rewrite.
Like 7 over 10. Or 10 over 7.
10 over 7. We're always going to do the power over the index. Derivative?
10 over 7 times x. Just be 3 over 7?
And I'll speed that up for you in a second. Question about any of that?
Oh, because you're only subtracting 1 from that, so that's why it's okay.
So what we've got going for those subtractions, if you have whatever power you have, 10/7 in this case, the derivative process always makes you subtract 1. Which in fraction land is probably making you think about
7 over 7.
7/7. And then we settle on the 3/7. Can anybody spot a shortcut way to like make that jump quicker without even like quite thinking through all that stuff? Bottom's just gonna, what happens to the bottoms when you do all of these every time?
Stay the same.
Stay the same, because it's subtracting fractions, common denominators, all of that. What's a quick way to just plop that 3 than what we have?
Top minus the bottom.
Top minus bottom. So just go top minus bottom gives you that. Like here, 1 minus 3, boom. 1 minus 2, boom. You can just keep the bottom and then just do top minus bottom, that gives you the top. So if I shoot up here, the 13th root of x to the 10th. In other words, x to the 10/13. The derivative would be 10/13 x
Is negative.
negative
Is it negative
3
3?
Over 13.
13. Just keep the bottom the same. Top minus bottom is what it is. Go on with your life. Something there? And there is a thing called a second derivative. So if I want to make my way, I'll make my way slightly left. This was the first derivative. That would be the symbol for the second derivative. Do you have a guess what the second derivative would be for that?
12x squared.
12x squared. All the second derivative means is to
Slope of that.
do it again.
Yeah.
If there's a second derivative, it sort of stands to reason, there's probably a third derivative, which would be
24x.
4x. And if there's a third derivative, there's probably a fourth. They won't do 4 of those things. They'll start to go like this for some reason. I guess they don't want to make the apostrophe 4 times. That would be 24. And there would be a fifth derivative, which would be 0. And I guess there's technically a sixth derivative, but it's 0, 0, 0. It's going to sit there and be 0 forever. A little bit of the homework, they'll ask you to find all of the derivatives, and that's what we just did over there. So if I step you in with this, the first derivative would be
Next weird. Minus 4x.
minus 4x. The second derivative would be
6x. Minus 4.
the third derivative
6.
would be 6. And every derivative from the fourth on
0.
would be 0. You do want to include 0 in your list, but you don't have to keep writing it for all you're going to do. And that's all I've got. We've got 4 rules. That significantly speeds up yesterday's process. Life goes on. Question on any of that? Okay.